So tell me some things about this picture. What can we tell that would help us work out the function that we're working with? Well, so one of the interesting things of flipping is that I can call this flipping also by doing shifts. So, you know, that there's going to be some different ways of doing this. There's not, again, not a unique answer to this.
You know that the amplitude is between -5 and 1.
Good. So that tells us something about the amplitude. If we go from -5 to 1, that covers a distance of how much? And that means the amplitude is 3. Amplitude is 3. Why? Because we go from -5 to 1, that's a distance of 6, and we divide it by 2. Because the definition of amplitude is not the distance from the top to the bottom, but half the distance, or the distance from the midline to the top. Speaking of midline, what could we say about midline in the sky? If the amplitude is 3, top is 1, bottom is -5, where is the midline?
-2.
Good. Okay. Now we just have to decide, are we going to talk about this in terms of sine or cosine? Because that's going to impact my thinking about the shift. Oh, well, sorry. Let me not get ahead of myself. Can we tell what the period is from this? I mean, I'm guessing that they're not using pi here. I'm guessing that these are nice numbers. So if this is -2 and this is 4, what is the period? What is the gap between this and this? 6. So let's work backwards. If t equals 6, then b equals, again, use the same equation. B equals 2 pi over t. All right, what did you find out about B? B equals pi thirds. Okay. All right, so now we're ready to talk about the shift. If we think about it in terms of sine, where sine should have been is the maximum should have been right at the top at the beginning. So in other words, there's been a little bit of a shift over this way. How much of a shift are we talking about? Looks like 1.
Wait, for sine? I thought sine starts on the origin.
Oh, good point. Yeah, sorry. That's cosine that starts at the top. And I think that actually would be the easier one to use, because I'd have to kind of think about putting myself here to think about sine and like what's happened in terms of that. So yeah, let's use cosine, because then we've got our sort of maximum expectation would be here right at the beginning at the origin. And that's a shift of 1 to the right. Shift of 1 to the right means what's the operation happening inside?
That inside is -1.
-1. All right, let's try it out. The proof is in the pudding. Y equals, amplitude was 3 cosine, pi thirds. I'm gonna leave this in its factored form because then I can see the shift clearly. And I got a D was -2, so I'm shifting it down. So let's see if this works. We should have a 1, 1 coordinate. We should have a 4, -5 coordinate. All right, let's find out. So we can put cosine x back on here. So we're going to go y equals 3 cosine x. Okay. And then we're going to -2. That's a good sign. Now we need to throw some stuff here in this inside. We decided b was going to be pi thirds. And we decided we were going to shift it by 1 to the right. Woo. Okay, let's check some things out. Now, there should be a point at 1, 1. That's a good sign. There should be a point at 4, -5. That's a good sign. Point over here at -2, -5. Yeah, these midlines, these are harder to judge, which is really what I would need for sine. Okay, cool.
Can you repeat what you said, meaning a midline versus the arc would help you? What did you mean by that?
So as I was looking at this picture, I was thinking, am I going to use sine or cosine? And I really could use either one, but I like cosine here because of the closeness of this top, right? So I could sort of visualize that as I just needed to move this pump over a little bit. Now I can still think about that in terms of sine, but because sine starts at the origin, it's not, I like to think about sine as like a shift on the origin point. But it's really easier to see shifts on maximum and minimum. So then, of course, the other way to do it would be to say, well, if sine has a maximum at pi halves, then I need to shift back this way. But now it's getting kind of murky because the pi halves has to intersect with the pi thirds. So it's just harder to think about what is the impact of shift from sine to over to that point right here. So I think cosine makes more sense for this one.
So when you might see one where the intersection is on a point, like on a real actual point, that might be a choice to actually pick side. Like if even this was shifted just a little bit to the intersection at the -1, -2,
yeah,
that would be.
This point we're sitting here, that would make it easier for me to see that.
Sweet. Okay. Sweet. Understand.
So how did you get the shift of 1 to the right again?
We looked at, so where we had got to, let me get back to this guy and take off the 1. We got to here.
Oh.
And we knew that that meant for cosine, this would be sitting at the top. And we knew that that really needed to be over at 1. So
okay.
That's where we got the shift right of 1.
So like we'll need to use a graphic calculator to find it, or make it easy.
No, I would say, I mean, first of all, you don't need a graphic calculator because Desmos does an amazing job of being able to easily put stuff in. You can see the way I've been working here. I mean, you can use the little keyboard here to get the pi sign, but you can also just type pi and it'll turn it into pi for you. / makes a fraction. So very easy to use, pretty user-friendly, I think. So no, what do I want you to be able to do? Well, I want you to be able to, first of all, make a table based on a function. If it's a complicated function, my expectations would be smaller, like a couple of points. But that's building off the unit circle knowledge that you have. And then I also want you to be able to apply your concept and knowledge of transformations. And this is going in both directions. So the example we just did, we took a picture and we tried to write a symbolic representation. In some ways, that's harder than looking at the symbolic representation and making a picture. But they're really just sides of the same coin.